Good evening, dear students. Yes, so we are discussing here the MCQs based on the first chapter, okay, of chemistry. That is some basic concepts of chemistry. Okay, so we have solved MCQs. Okay, so in the last class, so I think I have completed 2 classes on this particular chapter. That is some basic concepts of chemistry. Okay, so this is the third session where we are going to deal with some more questions of chemistry. Okay, so what are things we have seen here? So we have seen the mole concept, right? So we have seen the different this on mole concept. Then so different questions on mole concept. Just a second, I will share the synopsis part. Yes. So just a second. Okay, can you see the screen now, students? Is the screen visible? Yes. So in the last class, we were discussing the mole concept. So we have seen some of the questions based on mole concept. Then we had started with the determination of empirical formula and molecular formula. Okay, so that questions we need to see. And then there is some important terms, okay, which we are going to discuss in this particular chapter. That is mass percent. What do you mean by mass percent? How do you express mass percent? Mass percent is nothing but mass of the solute divided by the mass of the solution. Solution means together solute plus solvent, okay, into 100. So that will give you the mass percentage. Okay, this tells you the concentration of solution. So we can find out the concentration of solution in different using the different terms. Okay, so this is the first term, that is the mass percent. So how we are going to determine mass percent? Mass of the solute divided by mass of the solution into 100. Okay, then next is strength. So how we are going to determine the strength of any solution? So strength of the solution is decided by how much mass of the solute you are going to take, okay, divided by in how much volume of solution you are going to add. Suppose I have taken 4 grams, okay, suppose I have taken 4 grams and I have dissolved that 4 grams in 1 liter of solution. Okay, so this will tell you how much is the strength of that particular solution. Okay, so it will tell me the concentration. Same way again, okay, if I take 40 grams, okay, 40 grams of the solute and I add in 1 liter of solution, that is 1000 ml of solution. So what will be the strength here? The strength will be more here. Okay, so in the first solution where I have stored, we have taken 4 grams of solute and we have added in 1000 ml. Okay, so there the strength of the solution. So this way we tell the concentration. So concentration of the solution, it is okay, it is expressed like this. Okay, so strength of the solution. So how we are going to determine? Mass of the solute in grams divided by volume of the solution in liters. Okay, next is molarity, very important. Okay, molarity. In your board exam also they may ask you definitions. Okay, what is molarity, what is molality, what is normality? So these are some of the very important terms. So you need to know the definition as well as the formula. So by using formula, what we are going to do, we are going to use it in solving our MCQs. Okay, next is molality. Now okay, molarity, what is molarity? Moles of the solute. Okay, moles of the solute dissolved in volume of solution in liter. Now here molarity, it is expressed in number of moles. What is number of moles, students? Number of moles is given weight upon molecular weight. Okay, so how we are going to calculate this mole? Mole is nothing but given weight Okay, given weight upon the molecular weight. It tells you what? It tells you the molarity. So this number of moles, it is added in what? Okay, 1000 ml of solution. So volume of the solution is taken in liters. So this describes you the molarity. Next, we are going to discuss is molality. So molality is different. Molarity, it is expressed in capital M. Okay, and molarity, it is expressed in small m. So please remember the difference. Now, when we are talking about molality, so what again? Moles of the solute. Okay, moles of the solute means what again? How we are going to calculate the moles? Given weight upon molecular weight. Okay, given weight upon molecular weight upon mass of the solvent in kg. Okay, what is kg? Yes, 1000 grams. So kg is different, liter is different. So molarity is different, molality is different. In molality, what we are going to do? We are going to we are going to add the number of moles of the solute in 1 kg of solvent. Okay, and in molarity, what we are going to do? Number of moles of solute, it is dissolved in 1000 ml of solution. Okay, so what is solution? Solution is solute plus solvent. Okay, and solvent is always present in larger quantity and solute is present in lesser quantity. Okay, so this is about molality. Next is what? Next is normality. So how we are going to calculate normality, students? Normality is calculated as we are going to take the gram equivalent weight. Okay, we are going to take what? Gram equivalent of the solute divided by volume of the solution in liter. Okay, what we are going to do? Normality. Okay, we are going to take the gram equivalent. So we have already seen what is gram equivalent. So we are going to see the gram equivalent of the solute and we are going to take the volume of solution in liters. Okay. Then, so how we are going to calculate the number of gram equivalent? That is mass of the solute in grams and we are going to divide it by the equivalent mass of the solute. So gram equivalent we have seen. Okay. So by using this particular formulas, we are going to solve the MCQs. Fine. Okay. So let us go back to our MCQ part. Okay. So let us solve some more MCQs. Okay. So here are our MCQs. Okay. So let us start now. So we have solved the question based on molecular mass. Okay, so we'll not solve a molecular mass. So we will solve some different questions. Okay. Okay. So let us go for this particular question. So go through the question, students. 1000 ml of 0.1 molar. Okay, 1000 ml of 0.1 molar acetic acid is completely neutralized using a standard solution. I think this we have done or what? No. Okay. So 100 ml of 0.1 molar acetic acid is completely neutralized using a standard solution of NaOH. The volume of ethane obtained at standard temperature pressure. STP is what? Standard temperature pressure after the complete electrolysis of the resulting solution is A 112 ml, B 56 ml, C 224 ml, and D 560 ml. Okay. So what is the reaction? So they have taken, so I have told you, I have discussed with you what is titration, okay, in the last class. So there will be two solutions. One will be a known solution, one will be a unknown solution. So what we are going to do, so here one solution is our acetic acid. So what is acetic acid, students? CH3, okay, CH3COOH. The formula is CH3COOH, okay, acetic acid. So what is acetic acid doing? Acetic acid is reacted with what? NaOH. It is reacted with what? NaOH. That is our sodium hydroxide. So after reacting with sodium hydroxide, what we are going to get? We are going to get the sodium salt of acetate. Okay. We are going to get the sodium salt of acetate. Now this sodium salt of acetate, okay, what is happening? It will react with the water molecules. Okay, so how is the reaction? Just see taking place. So this is our sodium acetate. It reacts with the water, okay, in the solution, and it gives you what? It gives you ethane. Okay, ethane plus carbon dioxide plus 2NaOH plus H2. So like this the reaction goes. Okay, so here when we calculate the number of moles, okay, so the number of moles of acetic acid, so the number of moles of acetic acid is equal to number of moles of sodium acetate. So how much of number of moles of acetic acid reacts? No, that much number of sodium acetates are formed. Okay. So what is the this? It is 0.1. Okay. Into what is the volume? It is 100 ml. Okay. Into 100 ml is equals to, okay, so this is equal to how many moles? Yes, calculate the number of moles. The number of moles comes to be how much? 0.1 into 100.
10.
Just, yes, it is 10 moles. Very good. So it is 10 moles. So we have calculated a number of moles. How we are going to calculate the number of moles? That is what is the molarity into the volume. Okay, so it is 0.1 into 100, that is 10 moles. 10 moles is nothing but 10 into 10 raised to minus 3 moles. Okay, then when we are now here this is for acetate. Now when we calculate for sodium acetate 2 moles, right? So 2 moles, when you see the formula, so 2 moles of sodium acetate, okay, on electrolysis, it produces how many? At standard temperature pressure. What is the volume taken, students? What is the volume taken at standard temperature pressure? It is 22,400 ml, right? When we take the volume of ethane at standard temperature pressure is what? 22,400 ml. So 2 moles of sodium acetate when it undergoes electrolysis. Okay. So when it completely undergoes electrolysis, so 22,400 ml of ethane is obtained. Okay. So therefore, 10 into 10 raised to minus 3 moles is equals to, okay, of sodium acetate will be produced. Okay, will be produced. Now here, so what we are going to do? So we are going to cross multiply. So for 10 raised to minus 3 moles of sodium acetate, how much ml of ethane will be produced? So what we are going to do? We are going to do cross multiplication. Okay, we are going to do cross multiplication. So it will be 22,400 into 10 raised to minus 3. Okay, divided by 2. Just see how much you are going to get. Divided by 2. Just see.
112.
Okay, are you getting 112, everybody? Yes. So what we have done? So for 2 moles of sodium acetic acid, 22 at standard temperature pressure, how much volume it will be? It will be 22,400. Okay. So for 10 into 10 raised to minus 3 moles of sodium acetate, how much it will be produced? So it will be, so you have to cross multiply. Okay, what you have to do? You have to do cross multiplication. So after you do cross multiplication, so I am going to get answer as 112. Okay, everybody else has got this. Okay, so let us go for the next question. Okay, so the total number of electrons, in Yeah, okay. The total number of electrons in 18 ml of water, okay, whose density is 1 gram per mole. Okay, take it as mg. That this is small. Okay, so here, okay, the total number of moles, number of electrons in 18 ml of water is, okay, calculate, try to solve this, try to solve this. So the total number of electrons in 18 ml of water, density is given 1 gram per ml. Yes. So we know that one molecule of water contains, how much contains? It contains, okay, hydrogen contains 2 electrons and oxygen contains 8 electrons. So it is 10 electrons. Okay. So one molecule of water contains 10 electrons. Okay. Then if we calculate the mass, so let us calculate the mass of 18 ml. So how much they have asked? They have asked what is the total number of electrons in 18 ml of water. So ml, so volume, 18 ml of water. Okay. So how we are going to calculate? So mass, we know that mass is equals to volume into density. Okay. So we know that mass is equals to volume into density, or volume is equals to density by mass, right? So what we are going to find? We want to find out the mass. So mass is equals to volume into density. Okay. So what is volume, students? Volume is 18 ml. 18 ml. And what is density of water? Density of water is 1 gram. So what is the mass? Mass is 18 grams. Okay. Now let us find out the molecular mass of water. Molecular mass of water is how much, students? Yes. Oxygen is 16 plus hydrogens are 2. So it is 18 grams. So molecular mass of water, that is 18 grams of water, contains how many moles? It contains 6.023 into 10 raised to 23 molecules. So the molecular mass of water is how much? It is 18 grams. So 18 grams, how much it contains? It contains how many molecules? It contains 6.023. That is Avogadro number of molecules. Okay. So what we have to do? So you have to multiply 6.023 into 10 raised to 23 molecules will be there. So for that, so molecular mass of water, when we have calculated, it contains 6.023 molecules. So therefore, how many? So there are, so how many electrons are there? There are 10 electrons. So let us multiply 10 into the Avogadro's number. So Avogadro's number into 10 is how much? Just see, students. So they have asked us to find the total number of electrons in 18 ml of water. So in 18 ml of water, okay, so there are 10 electrons. So just see
60.23.
60.23. Okay. Uh, just try to convert. Let's see conversions. Okay, I'll see. So it is 10 into 6.023. So it comes 60.23 into 10 raised to 23. Okay. So if I shift this decimal this side, okay, so it becomes 6.023 into 10 raised to 24. Okay. So our answer is what? Option number C. Option number C. So the molecule of water, it contains how many electrons? 10 electrons. And what is the mass of the 18 ml of water? It is 18 grams. Okay, so 18 grams of water molecule, it contains how many molecules? It contains 023 into 10 raised to 23. Okay, that is Avogadro's number. So the number of whatever the number of electrons are there, so that you have to multiply by the Avogadro's number. So you are going to get the answer. So in our answer, okay, so it was what 60.23. But in our options, there are not like that. So we have to do the then what we have to do? Just move this decimal. Okay, so 60.23 decimal is there, no? So if I shift this one decimal to the left hand side, so it becomes, okay, so here it will be increase in the number by 24. Okay, so it is 10 raised to 24. Fine. Let us go for the next one. Okay. The number of moles of hydrogen that can be added to 1 mole of an oil is the highest in A. Linseed oil, B. Groundnut oil, C. Sunflower seed oil, and D. Mustard oil. Okay. So when we are calculating the number of moles, okay, so number of moles of hydrogen which is highest is in linseed oil. Okay, just remember not so important question. So option number A is the correct answer because linseed oil, okay, it has the highest percentage of unsaturation. Okay, unsaturation. So the unsaturation means double bond. Okay, unsaturation means double bond is present in the molecules. So in linseed oil, so more number of okay, so what is present? More number of unsaturation is present. So the highest number of hydrogens will be added to this. Okay, in the option number A. Let us go for the next one. Okay. Okay, let us solve question on empirical formula. Empirical formula of a compound is CH2O and its molecular mass is 90. The molecular formula of the compound is. So how we are going to find out this, students? Yes.
Ma'am,
Try
you
to
explain Kannada.
yes, empirical formula of a compound is CH2O and its molecular mass is 90. The molecular formula of the compound is A C3H6O3, B C2H4O2, C C6H12O6, and D CH2O. What do you mean by empirical formula, students? Yes, empirical formula. So we have discussed this all in synopsis. Okay, empirical formula, how we are going to calculate, and we have seen the formulas also, different formulas, right? So here, what we are going to do, empirical formula. Yes, so empirical mass. So first we need to, what all is given? So empirical formula mass. Okay, first find out the empirical formula mass of CH2O. So find out the empirical formula mass. Carbon is 12 plus hydrogen is 2 plus oxygen is 16. So how much it is? 6, 7, 8, 9, 10, 30. Okay. So empirical formula mass is 30. So what is empirical formula mass? It is 30. Next, what we are going to do? We have to find, so what its molecular mass is 90. So molecular mass is given as 90. So we have formula mass and we have molecular mass. Okay, empirical formula mass and we have molecular mass. Can we find out the number? Yes, n. So that is n is nothing but molecular mass divided by the empirical formula mass. Okay, so that is 90 by 30. 90 by 30. Okay, calculate. It is 3. It is how much? The 3 ones are 3s are. Okay, so it is 3. Okay, so it is 3. So now what we are going to do? What is the for next to formula? Molecular formula. Okay, molecular formula is equals to empirical formula. Okay, into n. So how we are going to find? So you have to multiply the empirical formula, that is CH2O into N, that is 3. So what is the formula, students? Yes, which is the answer? Yes, which is the option, students? A. Okay. Option number A. So C3H6O3. Okay, so it is option number A. Yes, very good. Okay. So what is given? So what we have seen in this particular question, empirical formula of a compound is given, that is CH2O. Okay. From that, what we have done, from that we have found out the mass. Okay, mass. We know carbon weight, we know hydrogen weight, we know oxygen weight. So we have calculated the mass of the given formula. Then what is given in our question? Molecular mass is given. Okay, so to find out the number, okay, the integer by which the this you are going to multiply. So what is the formula? The formula is molecular mass by empirical formula mass. Okay. So what is our molecular mass? It is 90. And what is our formula, empirical formula mass? It is 30. So divide 90 by 30, you get 3. So what is the, so when we want to find out the molecular formula, we have to multiply the number, that is your integer, into the empirical formula. Okay, into the empirical formula. So what is our empirical formula? CH2O into 3. Okay, so it is C3H6O8 or O3. Okay, so option number 8. Let us go for the next one. Okay. The mass of 112 cm cube of NH3 gas at standard temperature pressure is A 0.085 grams, B 0.850 grams, C 8.500 grams, and D 80.500 grams. Okay. So what is the mass of 112 cm cube of NH3 gas? Yes. So we know that at standard temperature, okay, at standard temperature pressure, what is the mass, students? So when we are calculating the mass of the, okay, at standard temperature pressure, that is NH3, nitrogen NH3. What is the mass of this? At standard volume will be how much? It will be 22,400. Okay, cm cube. So at standard temperature pressure, we have to calculate it with 22,400 cm cube. So what is the mass of 22,400 cm cube of NH3? Calculate NH3. Nitrogen is 14 and hydrogen is 1 each. So 14, 15, 16, 17. So 14 plus 3 is equals to 17. Okay, 17. So mass of the uh, ammonia gas at standard temperature pressure, that is mass of 22,400. See, whenever STP is given, we have to calculate the ammonia with respect to STP. Okay, so mass of 22,400 cm cube of NH3 is what? 14 plus 3, that is your 18, okay, so it is what? It is 17 grams. So at standard temperature pressure, the mass is calculated as 17 grams. So for 112 grams cm cube, for 112 grams cm cube, just a second. Okay. So for this is how much? It is 17 grams. So for 112 cm cube, it is how much? Yes. So we have to cross multiply. So whenever we are taking standard temperature pressure, we have to calculate it with respect to 22,400. Okay. So mass of 22,400 cm cube of NH3 is 17 grams. How we got 17 grams? Nitrogen is 14. Each hydrogen is 1. Okay. So we get 17 grams. So they have asked us to calculate the mass for 112. So mass of 112 Cn cube of NH3 is how much? Next, what you are going to do? Cross multiply. Okay. So it is 112 into 17 divided by 22,400. Find out what is the answer?
0.085.
0.085. Yes, very good. Okay, so it is our option number A. Okay, so whenever standard temperature pressure is given, we have to, so remember that we are calculating with respect to 22,400. Okay, STP means standard conditions. Okay, so mass of 22,400 cm cube of NH3 is 17 grams. So we have to calculate the mass for 112 cm cube. How much? Okay, so simple question, just a, so you have to take the standard ratio. Okay, and just cross multiply. Okay, let us go for the next one. Okay, so 50 cm cube of 0.04 molar K2Cr2O7 in acidic medium oxidizes a sample of H2S gas to sulfur. Okay, so volume of 0.03 molar KMnO4 required to oxidize the same amount of H2S gas to sulfur in acidic medium is A, what is option? 60 cm cube, B 80 cm cube, C 90 cm cube, and D 120 cm cube. So this was a question asked in 2014. Okay, this was a question asked in 2014. Okay, now we know that what is K2Cr2O7 student and what is our KMnO4. Can anybody tell me what is K2Cr2O7? What we call that? And what we call for KMnO4? Don't know? Don't know what is K2Cr2O7? Yes? Okay.
Potassium.
Potassium dichromate. Okay, 2. Chromates are 2 here. So it is potassium dichromate. And this is potassium permanganate. Okay, potassium permanganate. Do you know what type of solutions are these two? What are these two solutions? So these two solutions are what? These are the oxidizing agents. Okay. These are the oxidizing agent. Oxidizing agent. What do you mean by oxidation? Yes, what do you mean by oxidation? Oxidation means what? Oxidation means addition of oxygen. Okay, addition of oxygen is oxidation. Now, what is the role of oxidizing agent? Yes, what is the role of oxidizing agent? Anybody? Anybody knows what is the role of oxidizing agent? Oxidizing agent, it oxidizes other and itself undergoes reduction. Okay, oxidizing agent, what it does, it oxidizes other and itself undergoes reduction. Okay, so when it oxidizes other means what? It will add oxygen to the other molecule. Suppose A plus B giving you C plus D. So A is a oxidizing agent. Okay, A is an oxidizing agent. So what it is doing, it will oxidize other. Okay, and okay, so what it will produce, there will be addition of oxygen here and it will undergo reduction. Okay, reduction means what? Reduction means removal of oxygen. Okay, reduction means what? Removal of oxygen. So what is the role of oxidizing agent? Oxidizing agent means it oxidizes other and itself undergoes reduction. So both these K2Cr2O7 and KMnO4, both are oxidizing agent. Okay. Now here, so if we write, so what is happening here? 50 cm cube of 0.04 molar K2Cr2O7 in acidic medium. What it is doing? It is oxidizing the H2S sample. Okay. H2S is what? Hydrogen sulfide. Okay. And what it is going to do? So how this reaction takes place? So K2Cr2O7, if I take K2Cr2O7 plus it reacts with acidic medium. Acidic medium means what? H plus ions are there. So it takes up the 6 electrons to give you Cr plus 3 plus 7 H2O. So this is the reaction. Okay, so now your Cr is in plus 6 state. So from plus 6, it goes to plus 3. So what is happening here? It is undergoing reduction because there is a decreasing oxidation number. Okay, now here MnO4 plus, again this reaction is undergoing in acidic medium. Okay, plus 5 electrons giving you what? Mn plus 2 plus 4H2O. Okay, so here this is each oxygen is 2, so this is minus 8. Okay, so this is 2 into 4, 8, and this is plus 8. Okay, so now here what is happening here? So when we are calculating the, what they have asked us to find out, they have asked us to find out what? So how much volume of KMnO4 is required, okay, to oxidize? So 50 ml of this solution, it is required for 0.04 molar K2Cr2O7. So for 0.03 molar of KMnO4, okay, how much volume of H2S is required? So how much it is, students? Just cross multiply. So just what we have to do, we have to multiply it with the units. So what is the, how we are going to find the normality? Okay, normality or molarity, it can be calculated by the molarity. Okay, what is the molarity into number of electrons? Do it now. Molarity is given, so 0.04. Electrons are 6 electrons. Okay, and the second one, 0.03 for KMnO4. So this is for K2Cr2O7 and this is for KMnO4. Okay, so 0.03 into 5 electrons. Just see what is the answer. So for 0. It is 0.24 normal and this is 0.15 normal. Okay, so we have got now the normality. Now we have to find the volume. We know the formula, right? N1V1 is equals to N2V2, right? So for K2Cr2O7 and this is KMnO4. Okay, this is for K2Cr2O7 and this is for KMnO4. Now here, K2Cr2O7, what is the normality? 0.24. What is the volume of K2Cr2O7? It is 50 ml is equals to KMnO4. What is the normality? 0.15. We have to find the volume. Okay. So 0.24 into 50 divided by 0.15 is equals to V2. Find out the volume here. Find out the volume, students. Find out the volume. So we are using here the normality formula N1V1 into V2. First, we have found out the normality, okay, by multiplying the number of, okay, who has got it? Vaishnavi. Yes, Vaishnavi has got it as 80. What about others? The volume Vaishnavi has got is 80 cm cube. Okay, 80 cm cube. So first, we have found out the electrons, what are involved. So how we are going to find the normality by multiplying the molarity into its number of electrons. Okay, then we have to find out the volume. Okay, then we have to find out what? The volume. Is it clear now? Is it clear? Okay. Okay, find out this one. The number of water molecules present in a drop of water. Okay, so we know, okay, if we have a drop of water and this we have to find how many number of molecules are there of water in this, okay, present in this. The mass of this water drop is 0.018 grams. So find out the number of water molecules, students. How we are going to solve this? Yes, are we going to calculate the number of moles? First is what? Number of moles. Number of moles is what? Given weight upon molecular weight. Okay. What is the given weight? Given weight is 0.018. What is the molecular weight of water? Is 18. Okay. So find out. So what is it is? Yes. What is the number of moles, students? Calculate 0.018 divided by 18. Find out. Okay. 0.01. Yes, very good. Okay, so 0.001. Okay, very good. Or you can write it as 1 into 10 raised to minus 3. Okay, you can write like this also, 10 raised to minus 3. Now, next is what? Number of moles. Okay, let us calculate the number of moles. So, number of moles is what? Number of molecules. So whenever we are calculate the number of moles, so number of moles is what we are going to do. We are going to divide it by the Avogadro's number. Okay, what is Avogadro's number? 6.023 into 10 raised to 23. Okay, so what is number of moles? We have calculated number of moles is 1 into 10 raised to minus 3. Okay, so this is divided. So if we take it this side, so it becomes multiplied. Now you find out is equals to, so calculate the number of molecules. How much it is?
Option A.
Option A. How option A?
No, ma'am. Option D, ma'am.
Yes. Okay, because see here 6.023 into 10 raised to minus, 10 raised to 23 minus 3. So it becomes 6.023 into 10 raised to 20 because 23 minus 3 is 20. So our option is option number D. So our answer is option number D. So so what is given? So when we are calculating, so what they have given, a drop of water, it has the weight of 0.018. So you have to calculate how much molecules are present. So how we are going to calculate number of moles? Number of moles is given weight upon molecular weight. So from that we have calculated the number of, then you have to calculate the number of molecules. So how we are going to calculate number of molecules? You have to divide the number of molecules into its Avogadro's number. Okay, so we have number of moles, we have Avogadro's number, multiply it, and we are going to get the number of molecules. Is it clear? Yes. Okay. So if you okay. So some more questions are there on percentage and all. Okay. So that we will take in the next class. So one more class we are going to do on some basic concepts of chemistry. Did in your college did they start with structure of atom, second chapter? Yes. Did this complete the first chapter and started with structure of atom? Fine. So one more class we are going to do with this particular chapter. So in today's class, we have seen the questions on molarity, normality. Okay. Then we have seen the number of moles. Then we have seen the questions of empirical formula. Okay. So these were the questions which we have discussed. So in the next class, we are going to see some of the questions based on what we are going to see. So here percentage. Okay, again some questions based on the number of moles. Okay, empirical formula. uh, Fine, so these all, and limiting agent. So these all questions we are going to see in the next class. Okay. Yes, any doubts here? Any doubts, students? Okay, fine. So I shall end the session here. Okay, so we'll meet in the next class. Thank you.